All right, so we are gonna go over the bell ringer
Hey, why you break?
because it's not gonna be, because it was a screen, you wrote on the screen, not on the actual flip chart. It doesn't show on my video. I'm just trying to make sure it shows on the video. So this was 18, 25, 42, 45, 60, 20, 36, 45, 6, 55, and 18. For your slope, you're using this formula. If it helps you, you can label your points. This is x1, y1, x2, y2. I put it into the formula. 1, so my slope is 1 minus 2 over 3 minus 2. A positive and a negative. I keep the sign of the bigger one, so it's going to stay negative, and 2 minus 1 is 1. 3 minus 2 is 1. And negative 1 divided by 1 gives me a slope of just negative 1. Make sure you have your name on the front. Make sure you have your work shown for every one of these days. If you don't have that work shown, you're going to lose points. Just make sure you have it shown. All right, let's look at, again, your IXLs. Don't forget, are due Monday morning. Progress go out Monday, so by the end of today, what you see is what's going to be on your progress report, okay? So we will, the bell ringer quiz will go in, and the actual bell ringer paper will go in today as well. Make sure you have your bell ringers done for Monday. Your objective for today, so on the back, remember Monday was no school. This was Tuesday's objective. Friday's objective, Thursday, Friday was students will write and solve systems of linear inequalities. Students will write and solve systems of linear inequalities. Okay, so we are on page 210. We are continuing working with two variable inequalities. So these are making linear inequalities. We're going to be doing like 3 or 4 problems, and for all of them we're doing the same 4 steps. The first step is to read the problem, and write an equality to describe the constraints and specify what the variables are representing. The second thing we're going to be doing is graphing it. I will give you all a chance later to use Desmos, but I'm just going to put it up here and we're going to go from that. And then part C, we're going to name one solution and explain what it represents in that situation. And finally, we're going to answer the question that's like at the bottom of it, like right here. Okay? So we're doing all of those. We're going to practice 2. I'm going to give you all one to try on your own. So this first one, it says, School Environmental Club is raising money during the school year to donate in support of 2 causes. A national organization lobbying for clean air, so that's one of them, and a different one, a local nonprofit working to restore a stream that runs by the school. They plan to donate a maximum of $600 by the end of the year, some towards clean air, some towards the stream restoration. So they have a little bit of money going to, some of the money going to the clean air, some of it going to restoration. The max they want to spend is $600. So I start by defining my variables. Remember, you should write what I write. Let X be the money that they give to clean air. Given to clean air. And Y is the money given to stream restoration. So my first step is always to say what my variables represent. Y'all should be writing that. Do you need a pencil?
Yeah.
All right, so now we need to set up an inequality. The amount of money that they're given to the clean air plus the amount of money for the stream. We know that that's what they're giving, and we want it to be a maximum of $600. So if this is X plus Y is how much we give, and we don't want to give more than $600, would this amount be less than or greater than $600? Less than. Can it be exactly 600? A maximum of 1,600 means they're willing to spend all the way up to 600. So my inequality symbols here should be X plus Y is less than or equal to 600. So write that on your paper for part A. Part B says we're going to graph it using technology. Then we're going to sketch the solution on a region on the coordinate plane and label the axes. So we have to label the whole graph and everything. Let's go ahead and look at graphing this inequality. I have that X plus Y is less than or equal to, hold on, cancel. How do I move this? Hold on. Move this. It's not moving. Why is it not moving?
You trying to move the whole thing?
I'm trying to move my thing right here. Let's see if that worked. Okay, that's good, whatever. We should be good now. All right, so let me go back to minimizing. Anyway, so it should be less than or equal to 600. So I'm gonna have to zoom out so I can see what that picture looks like. I want you to notice that whenever we're doing word problems, they only ever show us the first quadrant because thinking about the amount of money we're giving, it's always gonna be a positive number. So we're only looking at our positive axis. So I see that the graph is going to go up to 600 on the Y, 600 on the X, and it's shaded below. I also see that it's a solid line. So let's go ahead and do the graph. First, I want to label it. This is the money donated. This is the side. The horizontal axis is my X-axis. What did I say that X is representing? We defined the variable. What is X representing? Heads up, everybody. What is it? Say again. Yep, so this is the money given to clean air. The Y-axis, the vertical axis going up and down, is the money for stream restoration. I need to have some numbers on my grid so I can plot my points. I knew that it needed to go up to 600, so what I'm going to do is count by 50, but I'm only going to mark the hundreds. So that would have been 50 there. This is 100. 150, 200. 250, 300, 350, 400. The reason I do that is if you try to write all the numbers, it gets really congested and then it's hard to read. So the top row, top line is my 600. Alex, head up. I'm going to do the same numbers going across the x-axis. 100, 200, 300, 400, 500, and then finally 600 at the end. So that should all be written for you already. Write it now. If you have not yet, go ahead and get it written. Are you even trying? Really? Okay. Is there anyone else whose bell ringer I did not pick up? All right, we saw from Desmos, when we looked at it, that my intersecting point for the y-intercept and the x-intercept was at 600. I saw that it was a solid line. The solid line means if something is on the line, it is still correct. And then it was highlighted below the line. So that's how the graph should look. All of that is part B. We are going to be doing some systems of inequalities in a little bit. If you have color pencils, it might be easier for you today to use those. All right, that's supposed to be it. I want all the numbers written. Everything that's written up there is what should be written on your paper. All right, part C says, name one solution to the inequality and explain what it represents. This whole shaded area, every single point in it is a solution. I'm just going to pick one solution. I'm going to pick this one right here. Just choosing a dot, okay? The ordered pair for that point, remember it's the x and then the y. So x value, it's at 200. My y value, it's over here halfway between the 300 and 400, so it is 350. When it asks you to describe what it means in context of the problem, you're going to be using your labels from your graph. It's the easiest way to figure out how to do that. If x is 200 and 200 is talking about the money given to Clean Air, that means the company donated $200 to Clean Air, and how much for the stream restoration? The y value is 350, so it's $350 for stream restoration. No, we've done a whole nother question since you stopped writing. All right, our last part D, says to answer the question about the situation. Here's the question. If the club donates 200 towards the streams, what can we say about the donation for Clean Air? So for part D, if they donate 200 to streams, how much do they have left? Huh? They're donating a maximum of 600. They've already given away 200. So that means they can donate up to $400. Or you could say $400 or less. Either way works. Oh, also I did want to talk to y'all about, some of you noticed something went into the grade book and changed. So when we take our district assessments, there was a couple of questions that had mistakes in the question. Back when we did one of the Unit 2 tests, I don't know if you remember this, but there was a grid that had on the horizontal axis, they labeled it Y, and the vertical axis labeled it X, and it confused a lot of people. So I wanted to give credit back for that question. And then also, I wanted to give credit for the graphing one that we did last test, because a lot of people knew what they were doing. They just didn't know how to graph it on that tool. Unfortunately, with the district assessments, I can't go in and add points at all. So I added a whole different column that just says adjustments. I made the possible out of 0 and gave you all 6 points back. So it's like adding it to your test grade because it's in the assessment category without the district seeing that I added it into the test, okay? So all I did was help everybody. That's all you need to really know, right? It just helped y'all. All right, so this kind of stuff is gonna be a lot of what's on our test that we are taking next Thursday and Friday for y'all. So let's do one more. How are we feeling so far? Okay. Let's go to our next one. You're gonna actually turn the page to the one about lawn. So flip the page and we're going to the question about concert tickets. The one about concert tickets, I think that's what it says up there. Is that what it says? Yeah, here we go, good. Concert tickets. Okay, we're doing the same parts, A, B, C, D. We're doing the same things, it's just a different scenario. There are two kinds of tickets to an outdoor concert that are sold. One of them is for lawn tickets, the other one is seat tickets. Fewer than 400 tickets were sold. My first part says to define my variables and set up the inequality. So let's say X is the number of lawn tickets. So what do you think Y is going to be? Someone. What's Y going to be representing? The seat tickets, yeah. So Y is the number of seat tickets. So you should be writing that in part A. X is the number of lawn tickets. Y is the number of seat tickets. Next, we have to set up our inequality. They sold lawn tickets and seat tickets, so X plus Y. And it says that this amount is fewer than 400 tickets. What symbol would go in there? Less than. Can it be exactly 400? It's fewer than 400 doesn't mean you can sell 400. Fewer than 400 means all the way up to $3.99, right? Okay, so fewer than 400 tickets. Part B says we're going to sketch our graph. Okay, just to see what this looks like so I know how to label my axes, I'm going to go to Desmos and type in my inequality. So it's basically the same, I'm just changing the symbol. The symbol is now less than and 400. So when I look at my graph, I see a couple things that might be a little bit different than the first graph. First of all, it's crossing, the X and Y intercepts are both at 400, and my line is dotted this time, or dashed. So I need to make my grid match that, and again, I have to label it. And I'm just going to move this whole thing up a little bit so I have some room for my labels. So this is the concert ticket sales. Going across the x-axis, what did we say X is? Lawn tickets. So this is the number of lawn tickets. The vertical axis is talking about the number of seat tickets. And I can use those same values because going up to 400, I'd still be using most of my graph. Get all that written out. Make sure you have your labels on it. The labels are really very important. It's also what's going to help us most when we're trying to describe what it means. We saw when we graphed it in Desmos that the y-intercept was at 400, the x-intercept was at 400. Because think about it, if you think about what that means, if they sold less than 400, if my x was 0, that means could sell my lawn tickets. If my x was 0, my seat tickets would be 400 or less than 400. And if I sold 0 of the seat tickets, then the lawn tickets would be less than 400. My line was dotted or dashed. The difference between the dashed line and a solid line means if the point is on the line, if it's solid, that means it still is a solution. For this one, since it's dashed, a point on the line will not be a solution. And then the shading was below. Okay, that should be dashed line, y'all. It needs to be a dashed line, not a solid line. And the shading goes below. All right, part C. Name one solution and describe what it means. I need any point in here. Let's do this point right here. I did the point 300, 100. So on the x-axis, I went to the 300. On the y-axis, to the 100. 300, since it's the x, look at this label. So that means they sold 300 lawn tickets and 100, the y is talking about the seat tickets. So pick a solution, then say what it means. And we could have all picked different solutions. Anything in that shaded region is a solution that would work. Right statement. What the point means. And then the last part is asking about this question, which I wish the question would have actually been over where they want you to answer it. If you know that exactly 100 lawn tickets were sold, what can we say about the number of seat tickets? We know that they sold less than 400 total tickets. If 100 tickets are already gone towards the lawn tickets, how many are still available for the seat tickets? How many total tickets? Less than 400, right?
100?
They already sold 100 lawn tickets.
Oh, 300.
So that means they can sell less than 300 seat tickets. Because they've already sold 100 lawn tickets. All right, the page on the side of it is what we're gonna do next, because I do want you to see that there is a difference when we talk about the money amounts. All right, raise your hand if you need more time here. All right, let's go to this next one. It says, lawn tickets cost $30 each. Seat tickets are $50 each. They want to make sure that their profit, or that they make at least $14,000 from ticket sales.
That's a lot of money.
Yep. So like before, we're gonna just say, let X be lawn and Y is suite. Y is the seat. It's the number that we sell. So this time my inequality, since each lawn ticket X is worth $30, this time it'll be 30X. Each of my seat tickets cost $50, so 50Y. And I want to make at least $14,000. So my amount, which is the part with the variables, should be greater than or equal to $14,000. I'm going to go to Desmos and type in my inequality. 30X plus 50Y is greater than or equal to $14,000. So my axes are crossing in different places. I'm still going up to the 200 here. I'm still going over. Let's use our same numbers as we did before. And we're gonna label our graph. So this is the money. Let me change colors so it doesn't all look like it runs together. This is the money made, or made however many we sold, right? Our x-axis is talking about the number of lawn tickets. Y-axis is talking about the number of seat tickets. I'm still counting the same way, so I label it the exact same as I did before. From the grid that I looked at in Desmos, let me go back and look. It was crossing at 280 on the y-axis. So it's gonna be a little bit above the 250, closer to the 300. And then on the x-axis, it crosses at 466, so a little bit past that 450 mark. Right in there. What kind of line does it have? Solid. So I'm going to use a solid line to connect this. And this time the shading happened above the line. So we're shading above because we were trying to go greater than or equal to. Greater than goes above the line, less than goes below the line.
I just looked up what the alligator is.
Do you want to copy of the book? I'm
Like-
so sorry, I didn't even think about that.
Whichever one he's using is bigger. You know?
Uh-huh. It has a name on it, but it's okay. I'm so sorry. Just remind me anytime. All right, part C says we're gonna pick a point and say what it means in context of the problem. I'm gonna pick this point over here. I want it to be a point in the shaded area. I chose the point, the X value was 500, the Y value is 300. What does that mean? That means they sold 500, what was my X label? Lawn tickets. And 300, what is the Y label? Seat tickets.
That's a lot of tickets, bro.
Now this last one is a little bit trickier for this one because we're not talking about the total number of tickets, we're talking about the total amount of money. So for part D, it's asking, if you know that there were 200 seat tickets sold, what can you say about the number of lawn tickets? So I'm gonna go back to my inequality, which was 30x plus 50y has to be greater than or equal to 14,000. And what they're telling me, when they tell me that there's 200 seat tickets, they're telling me to evaluate this when y equals 200. So I'm gonna substitute that value in there. I'll have 30x plus 50 times 200. And I want this to be greater than 14,000. So this 200, where it's coming from is because I said that the y value is equal to 200. I know that there was 200 seat tickets sold. And I'm going to use my calculator to solve this. Leave this one alone, bring down my 30x. When I multiply this, I get 10,000. And I want the total amount to be greater than 14,000. So just like before, when I solve my inequalities, I want to get the x alone. My first step is to subtract 10,000 from both sides. That leaves me with 30x is greater than or equal to 4,000. My next step to get the x alone, right now it's being multiplied by 30. Let's divide both sides by 30. So I need to sell 4,000 divided by 30. I get this decimal, 133.33. And it's repeating the 3.
That's a third.
Yes, it is a third. Very good. But we're talking about the number of tickets sold. Can I sell a third of a ticket?
Yeah, you watch a third.
Okay, no, you can't. Nowhere is they're gonna ever sell you a third of a ticket and let you in for a third of the amount of time. That's being ridiculous.
So you just go back
Oh.
down to.
So think about, if we go back down to 133, are we gonna make $14,000?
No, you have to sell 134.
We have to go up because I have to make at least 14,000. So what does it mean if they sell 200 of the seat tickets? That means they must sell 134 lawn tickets in order to make more than $14,000. Okay. Unfortunately, we have to cut because of the pep rally. We're not gonna get to do these practice problems. I want you to look at those practice problems for homework because we are gonna talk about them next week. But we do need to move on. This last part is taking, so y'all remember we started with linear equation, then we looked at a system. A system of a linear equation was when two lines intersected was the solution. We can have what is called a system of linear inequalities. So that's what we're about to look at real quickly right now. For your system of linear inequalities, the solution to the system is the overlapping region of the graph. In order to graph these, you have to remember slope-intercept form is y equals mx plus b. My first line I'm going to do is this one here. My m, what's in place of it? It's a negative, but it doesn't have a number. I know that it means a -1, and because slope needs to be a fraction, I'm going to put it over 1. What's in place of the b? A -1. B is -1. So I begin my graph at -1 on the y-axis. My slope is -1. You can think rise over run or the change in y over the change in x, the vertical change over the horizontal. So from my y-intercept, I go down 1 and over 1. The inequality symbol is greater than, but it's not equal to. That means I'm going to do a dashed line. Greater than means we're going to shade above. So this is where it's going to start to get very tricky, because this is, I recommend if you have colored pencils to use colored pencils for this. Because what we're going to end up having is two grids with two different colors, and we're looking for the overlap. So that is one of my linear inequalities. Close that Chromebook for now. The second linear inequality for this one here. My m is my slope. There's no number written in front, so I know it's a 1. My y-intercept is at -5. I go down to where the y-intercept, I go down to the -5. My slope is 1 over 1, so I rise 1, run 1. Again, it is a dotted dashed line. It is a less than, which means I'm going to shade below. Don't worry about remembering which direction you're shading, because we are going to have Desmos on this, and what's going to end up happening is you're basically just going to be typing it into Desmos and finding and looking at the graphs to match them. All right, so the solution to the system is the area that's shaded that has both of the colors. So when you see this on a test question, it is only going to be showing you, like, all of this red part will be gone. And it really makes it ugly if I do that. All of that red part will be gone. All of this blue part will be gone. The only thing that'll be graphed is that common area. Let's look what it looks like on Desmos. So on Desmos, when I'm graphing a system, we had y is greater than negative x plus minus 1 was one of our lines. My other line, y was less than x minus 5. All right, so what I want you to notice, so just like we had two colors, Desmos does this with two colors. The first equation, what we have in red, is shown in purple here. The second equation, what we have as blue, is shown in the black right here. The solution to the system is this section over here that is showing the overlapping colors. So every single point inside of this part, double shaded, will be a true statement if I plug it into both of those inequality symbols. Okay? This was fast. We didn't get to do as much as we wanted because of the pep rally, but